Ever wondered what the universe may be concealing in plain sight and disguised in a flash of light in the night sky? Imagine the scenario. On July 1st, 2025, scientists, with the help of the Atlas Survey telescope in Chile, spotted something that was extraordinary: a faint, fast-moving object that was passing through our solar system at an unbelievable speed of 58 kilometers per second. Initially, it appeared to be any other comet, however. Data kept on flooding in with world observatories, and the reality was realized. This was no local Oort cloud bum, but an interstellar, the third one to be verified, named 3I Atlas. And then, when the James Webb Space Telescope looked at it at the beginning of August, the discoveries were stranger than anyone could imagine. The chemistry of this space voyager is confronting all our understanding of the formation of comets outside our sun. Today we are going to immerse into this plot, examine the most recent data, what it entails as far as our knowledge about the universe is concerned, and why it brings arguments to the scientists. In case you too are as interested in the stars as I am, you may well stay. This is going to be a mind-opener. To begin with, we shall define the context in which 3I Atlas came into the scene. The ATLAS, or Asteroid Terrestrial Impact Last Alert System, is a NASA-funded system that is meant to detect potential asteroid threats to the Earth, but it has a habit of detecting cosmic surprises. On July of the same year, the Chilean telescope spotted an object whose velocity was approximately 1 or 2 times faster than the past interstellar visitors, such as the 1I Borisov and the 1I Oumuamua. The comet was first detected with ground telescopes, such as Gemini South, but a fuzzy coma, or cloud of gas and dust around the nucleus, indicated it was a comet, the second interstellar object to exhibit such activity. Contrary to the more rocky and cigar-shaped enigmas of the solar system, such as Oumuamua, which did not appear to outgas, or Borisov, which acted like our solar system comets, 3I Atlas was already displaying signs of life at very large distances, approximately 3 astronomical units away, which is approximately the same distance as Saturn is to Earth. The astronomers started to move on, as it was a chance in a million. Interstellar objects of this kind, as Marco Micheli of the European Space Agency pointed out in early accounts, are messengers of other star systems and bear some pointers to the planetary formation, billion and billion light-years distant. By mid-July, the Hubble Space Telescope contributed to the effort, snapping images that estimated the size of the comet nucleus to about 3.5 miles wide, that is, the size of a small mountain. The data provided by Hubble, as made available in the NASA archives, indicated that the trajectory of the comet was formed as a result of the thick disk of the Milky Way, a place which is filled with older and possibly older material. It is an indication that 3I Atlas was at least 7 billion years old, millions of years older than our own solar system. Suppose that, a fragment of ice and rock that has been drifting around the galaxy since the time the Earth was already formed, was thrown out of its home system, possibly by a gravitational slingshot around a planet or a close stellar collision. NASA Infrared Survey spacecraft. The SphereX mission was another tough blow to the others, as it observed a huge cloud of carbon dioxide gas surrounding the comet, but surprisingly small quantities of water and carbon monoxide. All these initial indications were fascinating, but when the James Webb Space Telescope entered the scene, it became the game-changer. JWST made its first observation into the heart of the coma of 3I Atlas on August 6, 2025, with the near-infrared spectrograph NIRSpec at a distance of approximately 332 AU, astronomical units of the Sun. It was not a fortuitous observation, but NIRSpec is created to disaggregate light into its individual wavelengths, and it is able to capture the chemical fingerprints of distant objects in incredible detail. The assessment of the data was conducted by a joint team of NASA, ESA and Canadian Space Agency, and the results were a bombshell. The comet has an overwhelming amount of carbon dioxide in its coma, and the CO2 to H2O ratio showed 8:1. It has 8 times more CO2 than water, the highest ratio ever measured in any comet, interstellar or otherwise. To put into perspective, normal solar system comets have ratio of approximately 0.7 or lower, and 2I Borisov was recorded at approximately 0.5. This discovery, which was presented in a preprint paper in the ESA site, has left astronomers scrambling their heads as it does not fit any of the known models of comet formation. To comprehend why it is so mind-bending, we will detail it down into an analogy that is easy to relate to. You can imagine a comet as a dirty snowball, which was created in the frozen outer regions of a star system, whereby particles of dust have volatile ices such as water, carbon dioxide and carbon monoxide, with the ices freezing onto the dust grains. Water ice is the most dominant in our solar system, as it is the most abundant, and as temperatures increase as the comet nears the sun, it sublimates or changes back into gas. However, to cause CO2 to overcome water on this scale, 3I Atlas must have condensed in a place where carbon dioxide was the queen of ices, perhaps in its protoplanetary disk, where the low temperatures permitted the CO2 to freeze, whilst water was gaseous or in low amounts. Alternatively, researchers such as Bryce Bolin at NASA's Goddard Space Flight Center propose that the long duration in the interstellar trip to the galactic cosmic rays could have changed the surface chemistry of the vehicle, forcing it out of water as a result of radiation effects. In any case, this comet is informing us that the building blocks of the planets of other systems may be extremely different than our own, and that there may exist worlds with CO2-saturated atmospheres that are the rule, as is the case with Venus in our backyard. But the statistics had not ended at ratios. The spectra of the JWST also showed some traces of carbonyl sulfide, OCS, a sulfur-bearing molecule, and is rarely found in such large amounts together with the weak signals of carbon monoxide, small water ice grains, and reddish dust being ejected at a rate of between 12 and 120 kilograms per second. The outgassing is also not symmetrical, increasing on the sun-facing side of the nucleus, as though the comet is waking up with an uneven wakefulness. This action so distant of the sun, when the rays are weak and most of the comets are in their dormant state, indicates that there is a thin, crusty surface that is easily broken through even by the heat of an object such as the sun, and volatiles are set free. Images of the comet taken by Gemini South Telescopic in early September reveal that the tail of the comet has extended to hundreds of thousands of kilometers and is growing at a very high rate as it flies inwards. And to add to the twist, there are recent images taken by observatories around the world that show the coma fluorescing a faint green, potentially because of the presence of diatomic carbon, C2 molecules that are even fluorescent under the ultraviolet light. But that here the rare chemistry adds to this effect. So now you may find yourself asking, all this strangeness, does it have any basis to the rumors that 3I Atlas may be something other than a natural comet? Its predecessor, Oumuamua, had already brought on such arguments, with Avi Loeb of Harvard proposing it to be an alien civilization of some kind, proposing that it was an artificial light sail because of its strange acceleration and form. In the case of 3I Atlas, there have been online forums and preprints pointing to its high CO2 level, like that of Mars or Venus, theorizing it might be a fragment of an ancient planetary cataclysm, or even a probe of some sort. In conversations, plasma physicist John Brandenburg has pointed out that the composition is dramatically different than any known comet, and goes back to myths of metals falling down to the Earth in the ancient society. NASA has, however, been swift to react by issuing official statements saying that the chemistry is indeed anomalous, but it can be attributed to natural processes in a wide variety of stellar environments. The no unexpected acceleration has been observed as in the case of Oumuamua, and the light curves exhibit a natural, although sharp, periodicity in the form of rotation. It's a wake-up call because the universe is full of surprises, and extraordinary claims deserve extraordinary evidence, and the evidence so far is pointing at an interesting natural anomaly rather than alien technology. This leads to the human aspect of the episode, which renders science so powerful. To coordinate these observations, NASA Jet Propulsion Laboratory and ESA Operations Center teams toiled round the clock to rearrange regular schedules to get brief data as the comet approaches the Sun. Scientists such as those working on the JWST spectra have dedicated years of research to the objects of the interstellar, who have built upon the legacies of the first researchers, such as the late Eugene Shoemaker, who changed the way we looked at comets and impacts. And, nor must we omit the ancient astronomers who were amazed by such visitors. In Egypt, Meteoritic iron with high concentration of nickel was used to make beads over 5,000 years ago, and it was a gift of the cosmos that was hammered into jewels worn by pharaohs. The omens in Babylonian tablets were about burning stones, which were a combination of fear and awe. We are now carrying on that tradition with telescopes in place of tablets, assembling together how these travelers exposed the variety of worlds beyond our own. In the future, it is not the end as 3i Atlas will pass the perihelion, the closest point to the Sun, at the end of October 2025, and will only come as close to Mars in orbit as 1.2 AU. Just as it warms, the outgassing of water may also rise, which may alter the chemical balance and cause it to become brighter to the ground observers. Orbiters, such as the NASA Maven, would be able to snatch close-up information, providing Earth-impossible views. Then it will swing away and can be seen until September, when it fades away in the glare of the sun, to be seen again faintly in December. In the long run, observations of objects like this might guide missions like the interstellar probe run by NASA that is planned to explore outside our heliosphere. In practice, the study of these comets can improve exoplanet atmosphere models, which could be useful in the search of life in other planets. Any lesson that 3i Atlas has taught us is that the galaxy is a carpet made of different chemicompounds, and we have to redefine the norm in cosmic evolution. To sum up, the new data of James Webb on 3i Atlas provides us with an image of the comet that is not only strange, it is also a gateway to alien worlds that we can never travel to. Having such elevated CO2 concentrations, ancient ages and dynamic activity, it is compelling scientists to reconsider how the planetary systems make their icy nomads, busting simple explanations and bringing about healthy argument, but it still makes us better informed in the end, reminding us that the universe is more complicated and wonderful than we thought. You think so? Is that a hint to carbon-rich worlds that are full of exotic life or another crazy traveler? Leave your comments below, and in case this interstellar investigation tour got your curiosity stirred, press that like button, subscribe to more science journeys, and show this to another scary space fancier. Until you get back, continue to look up. The universe has its interminable tales to recount.